Okay, guys, very quickly, we're going to learn something beautiful in this class. Are you with me? So, if you are with me, let's fire down as we look at the basicity of acids. So, under basicity of acids, what and what do they expect us to know? Very simple. Just go straight, right, and give us the definition of basicity of acids. Basicity of acid simply means the number, right, of replaceable hydrogen ions. In other words, let's say we have an acid, right? How many hydrogen ion is replaceable there? Or hydrozonium ion, right, that can be ionized in water. So the number of replaceable hydrogen ion or hydrozonium ion that can be ionized in water by one molecule of the acid. That's what we call basicity of the what? Of the substance or the acid. So what's basicity of an acid? It is the number of replaceable hydrogen ion, right, or hydrozonium ion that can be ionized in water by one molecule of the acid. That is called your what? Your basicity of what? An acid. Now, follow me, let me explain something. Also note this, that basicity of an acid represents the number of moles, right, of strong base. And that strong base there could either be your sodium hydroxide or your potassium hydroxide that is required to completely neutralize 1 mole of the acid. I like you not to cram anything. Understand this very well. For example, let's say we have an acid like your what? Your HCl. If it reacts with your base like your sodium hydroxide, right? What is it going to form? It's going to give you your salt and your what? Your water. We said that basicity of an acid is the number of moles, right, of a strong base. How many of these bases do I need to neutralize or react with what? 1 mole of the acid. So this is 1 mole of the acid. How many moles of this base do I need to carry out reaction with what? This acid to give me my salt and water. That is called your what? Your basicity. Of course, 1 mole of HCl will react with 1 mole of your what? Your sodium hydroxide. What is it going to give you? It's going to give you your sodium chloride plus your what? Your water at the end of the day. So what is basicity of an acid from the first definition? It is the number of replaceable hydrogen ions or hydrozonium ions that can be ionized, right, in water by 1 molecule of the acid. What do we call that? Basicity of the what? Of the acid. If you understand that and you get it to the core, as you move, you are going to get it more. But please understand this very fast. In 2012, they brought this question in question 19. The question says the number of hydrozonium ion that can be produced, right, by 1 molecule of the acid in the aqueous solution is its what? Option A, basicity. Option B says it is acid strength. Option C says it is no pH. And then option D now say, shut up, it is concentration. What is the answer? Basicity. Option what? A become the answer. The number of what? Replaceable hydrogen ion or hydrozonium ion, right, that can be produced from what? 1 molecule of what? Water. Or when it dissolves in water, how many of hydrozonium ion do you have at the end of the day? That will give you what? Basicity of the substance. In a more simple light, I like you not to forget this, that basicity of acid, right, we can describe it in 3 different parameters or explain it in these 3 different parameters. Number 1, the sort is called your monobasic acid. What is it called? Monobasic acid. From the name mono, it means 1, basic acid. Monobasic acid is also called your monoprotic acid. If you are feeling it and you understand it, just type clock it. So what do we call monobasic acid? It's also called your what? Your monoprotic acid. Number 2 is the one we call your dibasic acid or your what? Your diprotic acid. So it's either you call it your dibasic acid or your what? Your diprotic acid. Number 1 is called monobasic acid or monoprotic acid. Number 2 is called dibasic or your diprotic acid. Number 3 is called your what? Your tribasic or your triprotic acid. So the basicity of acid, we need to understand it under these 3 headings. The first is called your monobasic acid. Another name for monobasic acid is your what? Your monoprotic acid. Now come with me, let me explain. The definition is very simple. Just know from the name mono means 1. So monobasic acid produces 1 hydrogen ion per molecule in water. Or it produces what? 1 hydrozonium ion. Hydrozonium is H3O+. It is either when it dissociates, it gives one hydrogen ion, or when it dissolves in water, it will give your one hydrozonium ion, right? That is called your monobasic acid. Again, what is monobasic acid? Monobasic acid produces one hydrogen ion per molecule in water, or simply put, just tell us that monobasic acid will dissociate to give one hydrogen ion, or when they dissolve in water, it will form one molecule of your hydrozonium ion. If you get that and you understand it, let me show you something. Their general equation. Let's say we have this now. This is your acid. I said that when that acid, which is monobasic acid, if it dissociates, what will it give? It's going to give you hydrozonium ion plus your A negative, right? That's what you're going to have. So a monobasic acid, right, will dissociate to give one molecule, right, of your hydrogen ion. Or when it dissolves in water, this is your monobasic acid, it dissolves in water, what is it going to give? It's going to give hydrozonium ion at the end of the day. How many hydrozonium ion? One hydrozonium ion per molecule in water. If you get this very fast and you understand it, you see that it's simple. Look at this now. Let me give you a classical example. This is it. When your HCl, let's say HCl, if it dissociates, what is it going to give me? Hydrogen plus my Cl minus. You see, this acid now, as it dissociates, the question is how many hydrogen ion do I have I gotten from there? It has given me just 1 mole of hydrogen ion. That 1 mole makes it to be monobasic acid, also called your monoprotic acid. But when it dissolves in water, this is it now. HCl is dissolving in water. What is it going to give me? Is it going to give me 1 molecule, right? Whether you say 1 mole or 1 molecule of your hydrozonium ion at the end of the day, because it is just your H3O plus that we have. It's not 2 that is there now. It's just only 1 there. What do we call it? It is called your monobasic acid, or your monoprotic acid at the end of the day. Does it make sense? If you get that very fast with me, again, what is monobasic acid or monoprotic acid? You said that a monobasic acid, right, will dissociate to give 1 molecule or 1 mole of hydrogen ion, right? But when it dissolves in water, what are you going to have? 1 mole of your hydrozonium ion. What do we call that type of acid? Monobasic acid or monoprotic acid. If you understand that, what are the examples of your monobasic acids? The cardinal example is your HCl, because when it dissociated, you are there just 1 hydrogen ion, so you are going to have there, and then your chlorine ion. Another is your hydrogen bromide, right? Another is your hydrogen iodide. You also have your hydrogen fluoride. We also have your HNO3. Your HNO3 here is your triazonitrate 5 acid, right? Good. This is your hydrochloric acid, hydrobromic acid, your hydroiodo acid, your hydrofluoric acid, and so on and so forth. You get that very fast. Another is your HNO2, right? All of these guys are monobasic acids. And then now look at this. Pay attention to this. This here is your CH3, right? COOH. What is this called? It is called your ethanoic acid. What is it called? Ethanoic acid. This is ethanoic acid. Now, ethanoic acid, what is the basicity of ethanoic acid? This is a constant Jamb question. The basicity of ethanoic acid is 1, because it is only this guy that will dissociate, right, when it reacts with water, or when it want to dissociate on its own. In other words, your CH3, COOH, if this guy dissociates, what am I going to have? CH3, COO minus plus my H plus. Sure, you see now. That means out of how many atoms of hydrogen do we have there? This is 3 hydrogen here plus this 1. Total hydrogen is 4. Out of that 4, it is only 1, right, that we dissociate. And that 1 makes it to be monobasic or monoprotic acid. In other words, ethanoic acid is a monobasic acid, or your monoprotic acid. Does it make sense? Good. So this is your ethanoic acid here dissociate to give ethoside ion, and then your hydrogen ion. How many moles of hydrogen ion? Just 1 mole of hydrogen ion. Another example they may choose to ask you is your HCOOH, methanoic acid. You know, some people will say methanoic acid because there are 2 hydrogen there. It is the 2 hydrogen that, no, it's only 1. No, the basicity is 1. If this guy dissociates, what am I going to have? CO, that's your H, like the COO minus, plus my your hydrogen plus. So whether ethanoic acid or methanoic acid, the basicity is what? 1. Are you seeing it now? Because the number of replaceable hydrogen ion that is present in it is only 1, not 4, not 2, only 1. If you get that very fast. Now look at this. In Jamb 2008 question 16, they brought this question, and the question says the basicity of ethanoic acid is option A 1, option B says 2, C, then they gave D. What is the answer? 1. Option A is the answer. The basicity is what? 1, ethanoic acid. The same question, constant remark question. They brought the question in 2014, question 28. 10 years later, that's 2024, question 15. They brought the same question. The question said the basicity of ethanoic acid. Here you see now. So in your own case, they may decide to bring your HCOOH methanoic acid. The basicity is still 1. So what is the basicity? Is it 4? Is it your 1? Is it your 2? Or it is your what? Your 3? What is the answer? Option B. 1 becomes the correct answer. Does it make sense? If you get this and you understand it to the core, you are very, very sure. Let's fire down. Now, your monobasic acids, right, or your monoprotic acids, if they undergo neutralization, what will happen? Very simple. You need 1 mole of monobasic acid to neutralize 1 mole of the base that you are bringing in. So the base could be either sodium hydroxide or your potassium hydroxide. And when you do that, now look at this very fast. Let's say your HCl monobasic acid, if it reacts with your KOH, what am I going to have at the end of the day? I'm going to have my KCl, right, plus your H2 at the end of the day. So I need 1 mole of the acid and 1 mole of the base to go and form my salt and water for me. And the key terminology I like you to know here and never forget is the term monoprotic. We said that monoprotic acids are also called monobasic acids. So an acid that produces 1 hydrogen ion per molecule, what do we call it? Monoprotic. Protic there is telling you the proton. How many proton? 1. Monoprotic or monobasic what acid. Does it make sense? If you get that very fast with me, that's all. Number 2 is called your dibasic acid. Dibasic acid is also called your diprotic acid. What should I know? So instead of 1 hydrogen being formed here now, it will now be 2, right? So in your dibasic acids, don't forget, an acid is said to be dibasic when it produces 2 hydrogen ion per molecules in water. 2 hydrogen ion in water, right? So if it dissociates, I will have 2 hydrogen ion or 2 moles of your hydrozonium ion is what I'm going to have. A good example, look at the general equation. So we have your H2A like this as the acid. Acid dissociates. How many proton am I having there? So 2 hydrogen ion, right? So I'm having there. Plus my A2 minus. Sure, you see it now. So this type of acid, what do we call it? It is called your dibasic or your diprotic acid. If you get that very fast, a good example is the dissociation of your H2SO4. So when your tetraoxophasic acid dissociates H2SO4, what is it going to give me at the end of the day? 2 hydrogen ion is what I'm going to have. That makes it to be dibasic. So these 2 guys here, right, we undergo ionization. Plus my SO4 minus. That's all. And you're out of there. If you get this very fast and you understand it to the core. What are the examples of dibasic acids? Very simple. H2SO4, tetraoxophasic acid. Another example is your H2SO3. We also have your your oxalic acid. Pay attention. Pay attention. Which one is oxalic acid? Oxalic acid is your COOH, right? Like this to your COOH, right? Oh yes, ethane dioic acid. This is your oxalic acid. Either I call it ethane dioic acid or your oxalic acid, right? Good. So this guy here, you can see that from here we have H2. How many hydrogen? 2 hydrogen. How many oxygen? 4, right? And then carbon is 2, is complete, right? Good. This guy here, you see that there is something sweet about it. If it undergo dissociation, what am I going to have? It is going to give me 2 hydrogen plus, right? Your COO minus to my COO minus. That's what I'm going to have. Very simple. Does it make sense? Another is your H2CO3. And then we also have, in terms of your neutralization, don't forget that your dibasic acids, when they undergo neutralization, what will happen to them? 1 mole of dibasic acid is what I need. Your H2SO4, right? 1 mole of it is what I need to neutralize 2 moles of sodium hydroxide. So your H2SO4 plus your sodium hydroxide, how many moles? 2 moles of my Sodium hydroxide. At the end of the day, what is it going to form for me? It's going to form your Na2SO4, right? Plus your what? Your H2O. That's what you're going to have at the end of the day. So for every 1 mole of the acid, I need 2 moles of the what? The base to react. Are you seeing it now? So the key terminology here is the term diprotic. What is diprotic? An acid is said to be diprotic when it produces 2 hydrogen ions per molecule. What do we call that? Diprotic. So monobasic acids are also called your monoprotic acids. Your dibasic acids are also called your what? Your diprotic acids. And I gave you the key thing that they do ask in your monobasic acid as question. Ethanoic acid. Ethanoic acid, and then your metanoic acids. What are they? They are monobasic. The one that is dibasic, the cardinal example there when it comes to organic acid is your oxalic acid, also called your what? Your ethane dioic acid. Very simple. Does it make sense? Good. If you understand this and you get it to the core. Another key thing you must know is your tribasic acids. Your tribasic acids are also called your what? Your triprotic acids. Now, from the name tribasic, that means how many hydrogen ions do I expect there? 3 hydrogen ions what I expect there. Don't forget, from the definition, a tribasic acid produces 3 hydrogen ions per molecule in water, or 3 hydrozonium ion per molecule in water. The general equation is your H like this, 3A, right? If you dissociate, what am I going to have? Your 3H plus my what? Your A3 what? Minus. That's what you're going to have there. And don't forget the example there is your H3PO4, right? If you dissociate 3 hydrogen plus your phosphate ion, that's what you're going to have there. Pay attention to this now, because a lot of people, when they see questions here, they fail it anyhow. But it's simple. Let me explain. What is the example of your tribasic acid? Example of tribasic acid is your phosphoric acid. Your H3PO4 is your what? Your tetraoxophosphate 5 acid. Your tetraoxophosphate 5 acid. Under exam condition, when some people just read it, bam, they just see H3PO4. They don't even care whether it's SO4 that is there or PO4. They don't even care. They just rush, bam, tetraoxophosphate acid. They just rush basicity, it is 2, and then they fail it like that. This guy is your H3PO4. It is called your tetraoxophosphate 5 acid, right? Or your what? Your phosphoric acid. Don't forget, in terms of neutralization, I need 1 mole of my tribasic acid to neutralize 3 moles of your what? Your base at the end of the day to go and form salt and what? Water. You get that very fast. The key terminology here is your what? Your triprotic. Your triprotic. Triprotic acid is an acid that produces 3 hydrogen ion per molecule. Are you seeing it now? If you get this and you understand this, look at the key exam question here. 1987 question 2. The question that they brought here, the basicity of, some people just say tetraoxosulfate, they just rush, bam, 2 is the answer. Tetraoxosulfate, this one is tetraoxophosphate 5 acid. That is your what? Your H3PO4. What is the basicity there? The basicity there is what? 3. Option A, option B, option C, option D. What is the answer? Option D. 3 becomes the what? Answer, and you are out of there. If you get this very fast, that means you understand it to the core. Again, as I summarize very fast, under the types of acids that we have, what are they in terms of basicity? We have your monobasic acid, also called your monoprotic acid. We have your dibasic acid, also called your diprotic acid, and your tribasic acid, also called your what? Your triprotic acid. Now, your monobasic acid will give 1 hydrogen ion when they dissociate, right? Your dibasic will give how many? 2. Tribasic will give how many? 3, right? Good. What are the common examples of monobasic? Your HCl, HNO3, and then I told you that don't forget this guy, ethanoic acid, as well as your what? Your methanoic what? Acid, right? Those guys are monobasic. So, how many moles of base do I need to react with them to go and form their corresponding salt and water? I just need 1 mole of my base, right? NaOH or KOH to react with it. In your dibasic acid, don't forget that dibasic acid, we produce 2 hydrogen what? Ion. A good example, H2SO4, right? And then I gave every other things. And then I also told you that take note of oxalic acid, right? Also called your ethane dioic acid, which is your COOH, like this, to your COOH. Good. We looked at that, right? Perfect. And then don't forget that you need 2 moles of the base to react with the what? The dibasic acid to go and form their corresponding salt and water. And then your tribasic acids, right? What do I have there? 3 hydrogen ion is what they are going to form when they dissociate, right? A good example is your what? Your tetraoxophosphate 5 acid. That's the cardinal or the key exam question that they do ask. And of course, you need 3 moles of their corresponding base, right, to react with it to go and form salt and your what? Your water. That's everything about basicity of what? Acid from the beginning to the end. There is no question in the world under basicity that you will ever fail. If you understand this, click clock it or just type clock it and then we'll fire down very fast. Okay, let me show you something very little that you need to note. Importantly, I'd like you to know this very fast and don't forget that for organic acids, right, I stressed on this. In organic acids, only the hydrogen atom present in the carboxyl group is what is ionizable. So let's say, for example, ethanoic acid, right? CH3 COOH. This here is the what? The carboxyl group. Only the hydrogen that is in the carboxyl group is what is ionizable. This hydrogen here cannot be what? Ionized. That's why the basicity there is what? 1. Whether it is ethanoic acid or methanoic acid, the same rule apply. Cardinal example, ethanoic acid. Only this hydrogen here ionizable. This hydrogen, it cannot be ionized. That's why it is monobasic. Another example is your what? Your methanoic acid. Only this hydrogen is what? Ionizable. This one cannot be what? Ionized. Monobasic. Now, if you get that very fast. Another one I drew your attention to is oxalic acid, also called your ethane dioic acid. What is the basicity of this guy? The basicity is 2. It is what? Dibasic. Oxalic acid contains 2 carboxyl groups. This is 1 carboxyl. This is another carboxyl group. 2 carboxyl groups is what you have there. That's why their basicity is what? 2. It is dibasic or diprotic. Does it make sense? That's everything. Like without look and finish. But please, let me draw your attention to something very simple. When you dehydrate oxalic acid or ethanoic or your ethane dioic acid, where will it form? This is a constant jam question. I've given this to you before under drying agent and dehydrations. If you dehydrate this guy COOH to my COOH, if you dehydrate it, it means you will remove water, right? Just imagine it, you remove this guy like this, water. So you have removed. What is left? What is left are CO2 and then your what? Your CO. So dehydration of ethane dioic acid will give rise to 2 things. Your carbon 4 oxide and your what? Your carbon 2 oxide, right? Ahead. That one is simple. As we move, you are still going to see it. If you understand this very fast, that's everything about basicity of an acid. I'll see you in the next class. We are going to be looking at base in general. So we are done with everything about acids from the beginning to the end. The next lesson, we're going to be dwelling on your what? Your base. I'll see you there for the now. Bye.